Yeah, you're on the Hillbilly Voodoo channel. Do you have a problem with sticks and branches and yard debris all over your yard? Are you tripping over all this crap? Is it getting on your nerves and beginning to really annoy the hell out of you? Well, today we're going to see what we can do about this problem. We're going to build ourselves a wood chunker. No, not a wood chipper, a wood chunker. Stick around, see what type of hillbilly voodoo we're going to have to do to solve this issue. Now, not all of this yard debris has come out of my yard. We bring home branches, trees, old Christmas trees, so that our goats can eat them. It entertains them. They eat the needles off of them. They chew the bark off of them. By the time they're done stripping them, all you're left with was the branch or the stick or twig or whatever. No green stuff. And it's usually a fair size, but it's at that size where it's kind of annoying to cut up for firewood. Now, I do have an industrial wood chipper, but it's kind of it's one of those machines where if you got a huge pile of branches to do really quickly, then yeah, it's awesome. But it turns it into small chips. And as anybody knows, small chips compact, they don't dry out very well, and they don't burn very well. And I kind of feel a little bit bad about having all this wood laying around all the time that I can't use in my wood stove. If we chip it up, then it doesn't burn, and cutting it up, this small stuff's kind of a pain in the butt. So I want to create something that I can cut it up into about slightly smaller than fist size pieces that I can stick in the wood stove that's still going to burn. It's going to be big enough, fluffy enough that it will dry out and actually be useful. Instead of just piling it up into big huge piles and burning it outside, we can stick it in wood stoves and maybe create some heat. You can see we have a tiny house there that we use for our crafting studio, my sewing machine's in there, my editing stuff for all these videos, all that stuff. It's all in there, and it's heated with a small tiny wood stove, so nothing's bigger than the size of your fist will fit in that stove. So I'm thinking that building a chunker of some type is going to be a good idea, well, to provide heat for that, and maybe provide heat for the rest of the places around here. So let's figure out what we're going to do to build a chunker. So after doing some research and trying to decide what I want to build for a chunker, I decided that a bunch of flailing around blades and things like that probably isn't such a good idea with the luck that I have. So I'm going to make a screw or auger style chunker. Now you're probably saying, what the heck is that? Well, if you look around on YouTube, there's all kinds of guys building these auger style chunkers, but they don't speak English. I don't know what language they're speaking in, but I can't really understand. So I'm gonna have to try to figure this out by myself by looking at what they're doing and not understanding what it is that they're doing. Yeah, that made sense in my head, but kind of probably sounded stupid. Anyways, we need a shaft with an auger. So you guys know what an auger is, right? It's like a big screw thing that you use for drilling holes in ice when you go ice fishing or for transporting grain and stuff. It's more or less a big screw. Now we need to build this shaft with this auger so that we can feed the branches in on an angle like this, or even on an angle like this, and it will suck those branches in. We'll put a ring down here that this auger is going to spin around in. As it sucks the branches in, it will get closer and closer and it will chop them off. I think this is probably going to be the best idea. I want to stick it on the back of my mini loader, my homemade tractor, so that it's always on there, so that when I'm riding around the yard here doing my yard stuff and I see a branch on, I can just jump off and stuff it in the hole and it will chunk it up. Now what I will ultimately want to do is have bins that I can back over the top of, chunk them all up, it'll all fall into the bin. I can pick the bin up with the forks on the tractor, move the bin somewhere else, let that stuff dry out, and we can just scoop it into the wood stove, let it burn. That's the whole goal here, I guess. The idea. Now, whether this is going to turn out or not, it's another story, but this is what we're going to try out. Now, just like all of my other projects, it has to be built out of the junk that I have laying around, because like you all know, I'm just a cheap ass. Anyways, got to build it out of the ground obtainium, the stuff I have laying around here on the ground. So I think the first place we're going to start is by building this auger. Now we need a shaft, and we need the stuff to make the flighting on the shaft, the screw part. So let's go wander around and see what we can dig up out of the piles of ground obtainium to build a shaft, or to build the auger out of it. It might be a little tricky to find materials in the snow here, but I do know that I have a bunch of shafting stuff right by the door here. So we got some axles out of a big rock truck there, and we got an axle out of a Ford Super Duty. That'll probably be perfect material for the shaft. Not too big, not too small, just right kind of thing. So I think we'll use that, or a chunk of that, as our shafting. Now, the major issues that I have around here is having enough plate steel the same size and big enough for anything. So I don't think that we have anything readily available, but I do know that we have a piece of I-beam around here. Yeah, the quack pack's making noise again. I do know I have a piece of I-beam around here that I was using to scrape the snow the other day. And I'm pretty sure I left it in the snow pile over here. Yeah, it's kind of a common theme. Leave stuff in a pile and then go looking for it later on. Yeah, chunk of there's a chunk of I-beam right there. So how wide is that I-beam? I believe it's probably 3/8 thick, and it is 6 inches wide. Yeah, looks like about 3/8. It's been laying around here on the ground for probably, I don't know, 15 years or so. Like I say, I use it for scraping up snow and ice and goat poop and all that other stuff. So I think we'll cut our round disky flight things out of this. Wow, yeah, you're wasting a good chunk of I-beam. Well, it's not a good chunk of I-beam, it's a chunk of I-beam. Do we need for something else? Yeah, we need it for something else. So we're gonna cut our pieces out of this. Yeah. Shut up, let's do it. I'm not gonna pack this over the shop because my back hurts. So I'm gonna grab the excavator. Maybe I'll scrape some snow up with it while I pick it up with the excavator. And then we'll stick it in the shop and cut some pieces out of it. Now here's one for all you people out there trying to justify to your significant other why you need to buy one of those mini excavators, those little Chinese ones. You can use it as a snow shovel. Just grab your chunk of whatever in the jaws, and if you got like sidewalks and stuff you don't want to scratch up, use a piece of wood and you grab it in the jaws like that. And I don't know if I can do this with one hand or not, but see if I can prop you up here and show you how. Well, no, I can't do this, but anyways, use it as a snow shovel. Scrapes up the ice. You guys can't see this anyways, but here, I'll pile up a good pile of this stuff. You got to be a good excavator operator, but you can practice and have fun with your machine. I'll pile some of this stuff up here and show you what I'm talking about. See? Pile of snow, couple seconds. Couldn't video it because I can't do that. two-arm work the sticks and video at the same time. But anyways, there's another justification for why you need to buy a mini excavator toy to have around the property. And you can lift big heavy chunks of I-beam so your back doesn't get sore. Use this as an excuse. You're welcome. Now, I think before I get all stupidly overexcited here and start chopping into some good pieces of steel, better do a little bit of cardboard aided design and see if I actually know what the hell I'm going to do here. Now, I found a ground screw that we use to tether off some of our animals. Now, this will give you an idea of what I'm trying to build here. This is the auger style that I'm trying to come up with, but it's obviously got to be longer. It's got to have more flights to it, but this is kind of what I was trying to draw and what I was babbling away about. So we have to make this big like that. Now we know that our material, our chunk of I-beam, is 6 inches across, 6 inches wide. So that's the biggest that we're going to build to make this flight around. So that's a given, we know that. So let's find the center of this piece of cardboard here. And then we'll draw a circle that's 6 inches across. So what do we got here? I think it might be time to buy a new ruler. This one's getting a little, I can't see. So we'll set that at 3 inches so that we can draw a 6-inch circle. So the 6 inches of the I-beam is the only real given that we have. Now, to make this flight here, that hole in the center here, there's all kinds of calculations that have to go into making this. My math sucks, so I'm not going to do any calculations. We're just going to trial and error it here. That hole there has got to be bigger around than this size of this shaft, because we're going to be stretching it, right? And as you stretch it, that hole is going to compress. Just the way things work. Probably physics, probably yeah, whatever. Bunch of big words that I don't want to try to even pronounce. So that center hole there is what we're going to have to figure out. So I think we'll start out with a diameter that's just slightly larger around. Sorry, no, that would be a circumference, right? Circumference, which is just slightly larger around than the shaft here, so that we can stretch this piece of cardboard out, put it over that shaft, and give us an idea of how far apart this flight has got to be. So, let's cut this out. Arts and crafts with the hillbilly. When you get bored, you can go watch another channel. But if you don't get bored, you should probably subscribe to me. And you might learn something along with me. Yeah, that's enough singing. Okay, so we have our known 6-inch circumference. Now let's grab some calipers and find out how big around that shaft is. Now, some of you will notice that I do some stuff in metric and some stuff in imperial. That's because here in Canada, that's how we do things. We can't really commit to anything, so yeah. That being said, we build our houses in imperial, standard. Boards are all measured in feet, and we do pretty much everything else in metric. I really don't understand why they did that, and I've come from the background of construction, building houses, and from the background of mechanics and engineering, doing other things, and it just kind of messes me up crossing over. So we're going to do this part in metric. We have 38 millimeters. So that's 38 millimeters. Half of 38 millimeters, 17. So let's go down to 17. So if we make that hole 17 millimeters, it should just slide over the top of that. But that's not what we want to do because we want it bigger around. Yeah, so let's start out making that hole. Like I said, there's probably some big mathematical calculation and blah, blah, blah. Let's start out making that hole 20 millimeters. Is it kind of making sense? I hope it's making sense to you guys. If it makes sense to me, it probably should make sense to pretty much everybody else in the world. Okay. That's right, that should be a little bit bigger than our shaft. Yeah, okay. For some reason I'm thinking that that's not going to be big enough, that center hole, but let's try it out before we get all carried away here. Now, how can I do this so that you guys can see? So, put that over like that, stretch that out, so that it's touching. Currently between the tips of the flights we have approximately 3 inches. Does that seem right? Yeah, it's touching. So 3 inches, that's about that much. I wonder if that's going to be a good, because as it's cutting it, we'll cut it off each piece 3 inches long, right? Yeah, I think maybe that'll work. Maybe we should go just a little bit bigger. We can always fill the gap in here with weld, right? If it's too far out, we can make the spring shorter. So, yeah, let's make it just a hair bigger. Now, just a disclaimer here, I have made augers before, but I have never made augers like this. I usually just take a piece of ready rod or rebar or a round stock and I wrap it around in a spring, and if it's not high enough, then I just wrap another layer around and weld on top and keep welding. But I don't have any of that material now, right now, so this is how we're doing it. I've never made a chunker with an auger before. I've made augers for moving materials like grain and sand, mud, concrete, things like that. But this is going to be the first time for chunking up pieces of wood. I should probably get an X-Acto knife that's sharp. Just gnaw through this and pretend that it's sharp. Okay, so that's now 4.5 inches. Well, it's crazy how 5 millimeters, which is, I would say, pretty close to a 1/4 inch, 5 millimeters off of there. So technically it would have been 10 millimeters, which is pretty close to 3/8 of an inch. And that circle has given us 1.5 inches. So that's a little bit too big now. So we're gonna have to remember that 20 millimeters was too small and 25 millimeters was too big. Yeah. So let's make our hole in the center here 22 millimeters. So we're gonna write that on here. We're not gonna remake this cardboard thingy here. We're just gonna write that on here, and then when we cut out our little metal discs, then we will transfer the measurement on the inside here, and we'll say that it was 22 mm. We'll put a little arrow there so that we remember, which we're not going to remember. We're going to forget, and we're going to screw it all up probably and have to fill it with weld. Okay, so we know that this is going to work. We know that that's going to work. That shaft is obviously way, way too long, but I'm not going to chop it down yet. Now I'm thinking 3. We'll start out cutting out 3 of these little circles. So it'll give us 1, 2. Yeah, we'll start out cutting out 3. Now will give us about, I would say, probably pretty close to, well, if we go 4, if we go 3, the spacing between the flights is going to be around 4 inches, 3.5, 4 inches. So that'll be about a foot long auger. That should be plenty enough to grab the wood and feed it in. Yeah, so let's go and start hacking on that piece of metal and see what we come up with. Now I got 3 little 6-inch squares chunked out here out of that chunk of I-beam. I ground it off fairly flat and stuff. I've marked out our 6-inch circle with our center point punched in there. And I've taken the grinder and I've started to chew it down just roughly so that there's less material to have to whack off in the lathe. So I got these 2 sort of rounded out. I'm going to cut the corners off of this one, and we'll mount them up in the lathe and bore them all, or spin them all up so that they're all the same size, all the 6 inches across, nice and round. And then we will bore out the center to our 22 millimeter. That's what we wrote down there. Yeah, 22 millimeter. Hey, I remembered something. Yeah, and that's what we'll do. Now, bending these flights, it's going to be a chore. That's some thick stuff there. I would say it's, oh, let's measure it. God, I wish my eyes would work. You know what? There is a way easier way to measure the thickness of steel. You see these? These are called wrenches. Some people use them to throw. Some people use them as hammers. Some people use them for nuts and bolts. They have numbers on them. See, that one says 7/16. That one says 3/8. 3/8 don't go over the top of that. 7/16 just, yeah, 7/16 just goes over. The steel 7/16. You know, I could screw around with a ruler here for hours the numbers are all screwed up and the marks are all messed up. So why bother doing that? That's just dumb. So now we know it's 7/16. Anyways, blah blah blah. That's gonna be a chore to bend. We might actually have to yeah, we might have to stuff these things in the wood stove and heat them up red hot to get them to bend out into the spiral that we need. But we're getting ahead of ourselves, I think. Let's solve one problem at a time. Let's finish cutting these out, roughing them out, and let's get them on the lathe and round them out and bore our hole in the center. I got a piece of pipe clamped up here in the lathe that I've faced off. Now I'm going to take our roughed out circle with our center point marked out and use my live center and wedge that up against there like that. Now I'm going to tack it, just tack weld it onto this piece of pipe, then I can turn the outside edge round and then I can bore through the center. When the thing's all done, I can just cut the tacks off. Well, now that I got the machining work done on I'm going to cut the tacks off the back and we'll have our disc flight cut here. We'll have to split it across. Now this would be the time of the video that I tell you to like and subscribe and all that other stuff, but looking at my analytics, you're all adults, you do whatever the hell you want. This is obviously going to be a multiple part video or multiple part series on building this chunker, so if you want to follow along, hit that subscribe button or don't. Like I say, you're adults. You probably have people telling you what to do all friggin' day anyways. When I become an adult, I'm gonna do whatever I want. Yeah, that's a load of crap. Anyways, I'm gonna cut this off and I'm gonna try to think of some type of idea that we can start spreading these flights out. I think I have an idea that might work, but I'm not 100% sure. So you guys will be the first ones to know if it works, obviously. Okay, let's see if I can wrap everybody's head around this brilliant idea. Well, it's yet to be seen whether it's brilliant or not. I'm going to take this piece of pipe. This is our shaft. I cut it down to more reasonable length. I'm going to take this piece of pipe. I'm going to weld it to the top of this shaft. Everybody see that? Like that. Now I'm going to take our little ring. I'm going to put it over. First I'll put that over like that. I'm going to weld one side of our ring to the shaft. And I'm going to weld one side of our ring. I don't know if you guys can see what I'm doing here or not. To this piece of ready rod. Going up through this piece of pipe. Let's fumble around here and see if I can confuse even myself. Like this. This side will be welded to the shaft. This side will be welded to the ready rod. We're going to put a nut up here on the pipe, and we're going to start to slowly pull on this piece of ready rod, and hopefully we will get our 3 inches between one side and the other. I might have to heat this up with the tagger torch to do this and get it hot, but this is going to be our first attempt. Hopefully it will work. If it works, well, we'll be heroes, and if it doesn't work, well, we're gonna have to figure out some other way to do this. So I'll get this all set up here, and we'll see if it's gonna be a viable plan, or if we're gonna have to come up with some other idea. So in order to improve my odds of success with this goofy plan is, well, I'm gonna have to heat this up, I think. I'm gonna heat it up anyways, just to improve my odds of success. And we'll see what happens here. You can see I got my ready rod, my pipe. It's all welded together. See what happens. Well, it's moving, but I think we're going to be at it a while here. Well, I managed to get all of our flights on here now. This ready rod idea, it worked once I figured out that I had the wrong jet in my tagger torch, and I could actually get the metal hot without the tagger torch blowing out. So it's not perfect, but while I was screwing around with the tagger torch trying to figure it out, I started to think about what I was actually building here. Now, a screw is basically a ramp, and everybody knows that the steeper a ramp is, the more energy, the harder work it is to push something up that steep ramp. And the motor on my little tractor is not very big. It's only like, I think it's 10 horse or something like that. So unless I do a massive gear reduction, I had to make, anyways, I had to make the distance between the flights smaller, narrower, so that the ramp wasn't as steep, so that it didn't take as much, or won't take as much power to turn the auger. Does that make sense to you guys? I don't know what, it's physics, I think, or whatever. But anyways, the steeper the ramp, which if the flights are farther apart, the ramp's steeper, the more force it takes to move the thing uphill. So, me screwing around with the torch kind of probably saved me a little bit of grief in the long run. The flights are still fairly far apart. They're 2 inches, I think it was. I measured. Two and a quarter inches. Sorry. So that's still going to give me pretty big chunks of wood. Should still work. Now I'm going to spend some time with the grinder here and clean up my welds and make sure that I actually got everything welded in a way that's going to do what it's going to do. And then I'm going to go take a look at the tractor again and make sure that I remember which way the crankshaft is turning. I'm pretty sure that the crankshaft is turning counterclockwise. So if the crankshaft's turning counterclockwise, then this has got to be the end that mounts to the crankshaft, right? It's going to screw in like that. And we want the material to go that way. So yeah, that's the way it's got to go. So I'm going to do a little bit of grinding here. I probably won't show you guys the grinding because grinding's boring and it's loud and it's annoying. So I'll bring you back when maybe it looks a little bit better, and we'll decide what we need to do from there. Well, I got most of our welds cleaned up here. I didn't get too mental with it and just tried to smooth it out as best I can so I wasn't snagging my body parts on anything. And I have not sharpened these flights yet because, yeah, I don't want to cut myself while I'm working on this thing. So I'll probably wait until the last step of this whole project to do that. They didn't turn out too terribly bad. Now, things that I've learned so far is that I would have just spread each one of these flights just 7/16 of an inch out and welded them all together first and then stretched them out over this. I also would have made that center hole bigger, so that would have been easier to stretch out and then just fill up with weld. And it probably would have made this go a hell of a lot smoother. Another thing I learned, 7/16 steel is probably super overkill for what I'm going to be powering this thing with. I could see if maybe I was powering it with a big huge diesel tractor or something like that, but the tiny little motor I'm going to be running this thing with is, I'm pretty sure we ain't going to snap these flights. Yeah, that's what it is. Why would I just welded all these together with a little bit of a gap in between them? Because if you look right there where I did weld them together, they had already kind of bent and deformed a little bit. Like, it was kind of hard to get them all lined up after they were stretched out. So if they were really close together, it probably would have been a lot easier to line that up. The flights probably would have turned out a little more straight, but they're pretty good, especially for my first time doing it this way. So I think I'm going to leave this video here. If you guys got some comments on whether I should sharpen these at just a bevel or hollow grind them, leave those. If you got any experience on these chipper things, leave a comment whether I should hollow grind the edge or whether I should just single bevel it. And like I say, I'm going to leave this video here on a good note. It's going to be a multiple part video or multiple part series, so if you want to follow along, well, maybe you could subscribe. I mean, you don't have to subscribe if you don't want to, because you're adults, but you want to make your life easier, then yeah, blah blah blah. So until next time, guys, use what you got to make what you want, and I'll see you later.